So, hi everybody. Today I will be discussing pseudo force. So, what pseudo force is? Um Suppose this is some bus, and suppose some person is standing in this bus. Suppose some person is standing in this bus. Experience yourself, like you might have seen a lot of times, like a debate. I will show you what's happening here. So the thing is that what's happening here is that the driver here, what he does, he started accelerating the bus. Means he started doing that he started accelerating the bus. So you might have seen a lot of times while traveling on bus that whenever the driver accelerate with some means whenever what acceleration means he's trying to increase the speed. So when your bus accelerates, so you experiences like a backward push you used to experience means you like whenever you travel on bus, what happens like when your bus accelerates, you will experience a backward force, like backward push you will experience. So, like similar in the case when your driver puts a brake, means okay, this is for accelerating part. Okay, so the thing is this here, this bus is accelerating. Now here, what happens that the driver start putting the brake. When he will start putting the brake, it will start de-accelerating. De-accelerating means acceleration in opposite direction, or minus a you can say. Means here what's happening that he driver start putting brakes. So speed will decreases. So like if some person is standing here, you actually it's a general experience you might have seen. So you will feel a forward push. You will feel a forward push. Like you might have seen if someone puts the brake suddenly, all of a sudden, so you will jerk. You will get a jerk on forward direction. So you might have seen like whenever someone puts a brake in you, it may be your car, it may be a train, it may be a bus, anything it might be. So like whenever it accelerate, you will feel a backward force. Like you will feel a backward force. And whenever the brake is means whenever brake is applied, like in train or in car or in bus, anything, whatever it is, so you will feel a forward jerk. Like you will come, it means you will feel it. It means you might have experienced this thing in your daily life a lot of times. So it's a basic thing. So whatever force you are experiencing, like a backward jerk when the body is accelerating, a forward jerk means no one is doing nothing. But the thing is that whenever your when brake is applied, you will feel a forward jerk, means a force in forward direction that will make your body moves forward direction. So this whatever force you experience here, like when you are traveling in bus or when you are traveling in train, when you are traveling in your car. So what this force? This force is called a pseudo force. This force is called the pseudo force because like it's an invisible force. The thing is that you used to experience it. No one is applying any such force on you, but you used to experience this force. So this type of force, like the thing is that or in other words, you can see like when your bus is traveling in forward direction, you will experience a force in backward direction. When this same bus is deaccelerating, means you can see here like this, your bus, the acceleration will be in this direction. That's why that's why your bus will start deaccelerating. So you will experience a force in forward direction. So this is what is called as a pseudo force. So it's a basic idea, and you might have came across every day in your daily life. You came across this pseudo force while traveling in bus, while traveling in train, while traveling in your car. So you used to experience this type of jerks every day. So remember this thing that the direction of this force is opposite to the direction of acceleration. So let's see how we are going to calculate it and what would be the things that should be kept in mind while doing the calculation part. So it's a general idea like what pseudo force is. Let's move to let's see another thing. Let's see the same thing. This is some wedge. and some block is kept over it. What I am considering that this surface, the friction between this surface and this surface is smooth, and the friction between this surface and this surface is also smooth. You can say there it's a frictionless. Now what I will be doing, uh, I will make this wedge accelerating in this direction. Suppose it's A naught and it's accelerating. It's not deaccelerating, it's accelerating. So as I told you that when some person is sitting on a bus, he will experience some pseudo force. So here also, suppose the mass of this block is m. Remember this thing that the surfaces are this surface and this surface. Both are smooth. So here there will be a pseudo force. This block M will experience a pseudo force in this direction. That will be here what acceleration is A naught. So it will experience a force M A naught in this direction. Suppose uh, like I told you earlier that or I am going to show you another thing also like this is some block and another block is kept over it like this, and the mass of this is m, this one is capital M, and it is also accelerating in this direction. Acceleration in it's accelerating. So same thing you will see here that it will this block the thing is same thing. Remember that this part is this surface is smooth and this surface is also smooth. Okay, means there is no friction. So here also this block will experience a pseudo force. What is this? It's a pseudo force. Okay, so what pseudo force it will experience? This will also be m a naught. M a naught. What is this? It's a pseudo force it is going to experience. This angle is theta. So no need to see now this section. I am going to do the analysis of this section. So we are done with the analysis of this section will become much more easier to you because it's a simple block to block. So let's do the analysis of this section. So let's draw the free body diagram FBD. Let's draw it for M part. So like there will be what? There will be mg force which will be acting downward. There will be some normal reaction that will be perpendicular to the plane. Okay, and this ma force that I already told you is acting in this direction. Now suppose this block is going downward, this block is going downward with acceleration a, and with respect to this wedge. What is this? This is wedge. This is block mass m. uh, this one is block of mass m, and this is wedge. This triangular part, whatever it is, it's a wedge. So this, like this, this block will come down with acceleration a, that is with respect to wedge. Okay, the let me explain you what does it mean with respect to wedge. Suppose I am standing on this wedge. This wedge is moving with acceleration a naught. This wedge is moving with acceleration a naught, and suppose I am standing here on this wedge only. I am standing on this wedge only, and this wedge is moving with a naught. Okay, the thing is that when I am standing on this wedge, I will say, means what I will see, you can say, I will see the acceleration of this mass m a. I will see, when I am standing on this wedge, I will see the acceleration of this mass a. Suppose I am standing on the earth. Let us suppose in another part, if I am standing on earth, then it will not be a naught. This will not be a naught. It will be something different, because you can see it like here, like this a is with respect to wedge, means with respect to wedge you can say that it is viewed by a person who is standing on the wedge. And when I'm saying that this person is standing on, if some person is standing, if I am standing on earth, then in that case, if I am going to say something about the mass, this mass m, so that will be with respect to earth. So the thing is that this acceleration is with respect to wedge, means you can say that the person is standing on this wedge says that he will see that this block is moving down with acceleration a. So here you can see like this block is moving down with acceleration a, and what this acceleration is with the respect to wedge, with the respect to wedge. So let's do the component part. When I am going to divide the mg part, this will be theta. So it will be two components of mg. mg cos theta, mg sin theta. Let's do the same thing for ma. So ma in this direction, this is theta. So this will be m a naught cos theta, and in this direction what would be the component? M a naught sin theta. So what we have here? What we have here? Let's check the like this force and this force is balanced by what? N. This force and this force is what? Balanced by N. So what our equation will be? You can see like direction is in this direction, and in this direction. So it will be balanced like this. So what we have the equation? This is equal to m a naught sine theta plus mg cos theta. Now this force and this ma naught cos theta means this direction and in this direction. What is the net force? The thing is that this blockage. Okay, the thing is that this block will move upward, not downward. I made a big mistake here. Like this block, yeah, this block will move upward direction, not downward. It will move in upward direction, not downward direction. This block will move in upward direction, and that is with respect to wedge. So what is the net force in this direction? In this direction, so you can see like in the direction of acceleration, what is the net force? M a naught cos theta. This one m a naught cos theta minus mg sin theta minus mg sin theta is equal to what? This acceleration is there, like we have F is equal to m into a, that we already. So this is the net force acting in forward direction, and what is the acceleration here? M into a. Remember this thing, this acceleration is with respect to wedge, means with respect to person standing on the wedge, you can say. So what would be the a? A will be a naught cos theta minus g sin theta. So if someone asks you like this wedge is moving in this direction with acceleration a naught, and what would be the acceleration of mass m placed over it with respect to wedge? If someone asks you that what would be the acceleration, like this acceleration is with respect to wedge. This is not with respect to earth. This a naught is with respect to earth. Means if I am standing on earth here, so I will say that this wedge is moving in plus x direction with acceleration a naught. So if someone asks you what would be the acceleration with respect to wedge, means with respect to the person who is sitting on wedge, you can say. So this would be the way by which you are going to find it out. Let's do a bit of modification on this in this scenario. Suppose this is your earth and this is your wedge. This angle is theta and some block is kept over it. Mass of this is m and this one is capital M. Remember this thing that I am considering this surface and this surface smooth, means it is frictionless. Now what's happening here is uh, this block, this M block or wedge, this is what? Wedge. We used to say it wedge. This one is block. So like what's happening here, like this wedge is moving in this direction with acceleration a naught. With acceleration a naught. So what will happen? I told you that there will be a pseudo force which will be acting in this direction. That is m a naught. The thing is that this block will not lose contact. This block will not lose contact means like you while traveling on train you might have seen when train accelerates or one bus accelerates. If you are standing on a bus, you will feel a backward push and you used to move your position. Means what happens that you sometimes you move backward or sometimes few people fall on the floor because of this jerk. So means what my condition is that this block will remain in touch with this surface, this wedge. Like there will be, it will not lose contact. This will remain in contact throughout the. This block will remain in contact with this wedge. It remains in contact with wedge because it is experience m. It is experiencing a force m and not pseudo force. This is what pseudo force. So it is experiencing a pseudo force ma naught, but it will not. It is not losing its contact with the wedge. This is my condition that I don't want that this block should lose its contact from the wedge. So suppose this block is moving down. This block is moving down acceleration A. And what is this acceleration? With respect to wedge. And as I told you, what with respect to wedge means? With respect to a person who is standing on the wedge, you can say. Means if someone is standing on this wedge, and if I am means if I am standing on this wedge, and what I will see or means that this block is moving down with acceleration A. Okay, so let's draw the free body diagram. That's the main thing. Remember this thing that this scenario includes a lot of forces. So let's draw the free body diagram. First I am going to draw the diagram of this M. So first I am going to draw the diagram of this. So like mg will act downward and this ma naught will act in this direction. Now there will be a what? Normal force perpendicular to the plane which will be acting. What else is there? Nothing. What about the wedge? The main thing is here that there is a acceleration. It is moving down with acceleration A. It is moving down. It is moving down with acceleration A with respect to what? Wedge. Let's draw another free body diagram of this wedge. So this wedge is moving in this direction with acceleration A naught, and this acceleration is with respect to Earth. So as the normal force is there, here also it will experience a normal force. That's the action and reaction part, or Newton's third law, that in every action there is equal and positive action. So there here also this block will experience a normal force here. Now let's create the components. Let's see the components of these forces. So this one is given theta. So this will also be theta. So it will become n sine theta. Okay, sorry, it will become n cos theta. And this will be n sine theta. So what equation we have here? The mass of this is m. The force in this direction is what? You can see here like this is n sine theta in this direction, n sine theta in this direction, and acceleration is also in this direction. What would be the equation? The equation will be n sine theta is equal to capital M A naught. So let's do the components of this part. So this one will be theta. So like this will be mg cos theta, and this one will be mg sin theta. What about this ma part? Uh, think yeah, this one will be theta. This yeah, this one will be theta. So this will be ma naught cos theta, and this one will be ma naught sin theta. So the thing is, my condition is that it remains in contact with the wedge. So the thing is that whatever forces like this n is acting in this direction, this ma naught sin theta in this direction, that should be balanced by this mg cos theta. Because if n plus ma cos theta, because you can see like n plus ma naught sin theta is acting in upward direction, so that should be balanced by what? Mg cos theta. As we don't want that it should lose contact, should be Mg cos theta. Now let's see like in this direction what force is acting? Mg sin theta, ma naught cos theta. uh, let rename it like this is equation 2, this is equation 1. Okay, so like in this direction what are the forces? What are forces are like mg sin theta in this direction, ma cos theta in this direction, and what this acceleration is with respect to wedge. Remember this thing that this acceleration is with respect to wedge. It's not with respect to earth. This is with respect to wedge. That's the main thing. With respect to wedge. So what would be the equation? Like this will be mg sin theta plus ma naught cos theta is equal to what? Like this is the force in downward direction and this is the acceleration. So like this will be ma. This because like as I told you in downward direction F is equal to ma. We know force is equal to mass into acceleration. So like here the total force in downward direction is what? F this mg sin theta, this ma naught cos theta, and what it will be equal to? Ma. And what is this A? That is with respect to wedge, means as seen by a person standing on the wedge, not with respect to earth. This is with respect to wedge. So like this is your third equation. Now do one thing, multiply second equation with sine theta. So what it will become? It will become n sine theta. Multiply this second equation by sine theta, so it will become n sine theta plus ma naught sine square theta is equal to mg cos theta sine theta. Okay, and put sine theta, put n sine theta is equal to ma naught here. So it will become m a naught plus m a naught sine square theta is equal to mg cos theta sine theta. Make this equation number as 4. Make this equation number as 4. Now in third equation, multiply third equation by cos theta. Multiply third equation by cos theta. Okay, so when I am going to multiply the third equation with cos theta, it will become mg sine theta cos theta plus ma naught cos square theta is equal to ma cos theta. Let's do one thing. Substitute this. You can see it like mg cos theta sine theta and mg cos theta sine theta both have the same thing. So this equation 3 and 4. What I will be doing that I am going to substitute this mg cos theta sine theta is equal to what? ma naught sine square theta. So I am going to substitute this part with mg sine theta from here. So it will become ma naught plus ma naught sine square theta plus ma naught cos square theta is equal to ma cos theta. So as we know sine square theta, if you don't know then remember this thing, sine square theta plus cos square theta is equal to 1. This equation you will come across in your trigonometry part. If you don't remember it, then no issue. Remember this thing that this you will come across in your trigonometry part. So like you can see here, like this ma naught sine square theta, ma naught cos square theta. So if you are going to take ma naught common, it will become sine square, like this equation will become like this: ma naught plus ma naught sine square bracket में sine square theta plus cos square theta is equal to ma cos theta. So when you are going to solve this, it will become like this. This equation will become like this. Because this sine square theta, cos square theta will become 1. So we have this a naught m plus m is equal to m cos theta. And what is this? A. So this is the final A acceleration we got. And what is this acceleration? Acceleration of block M with respect to what? Wedge. So if someone going to ask you that what would be the acceleration of the mass M with respect to wedge, you are going to find it out in this way only. Okay, so I think now you have a good idea about what pseudo force is and how we are going to use it in our numerical part. So that's all for today, and yeah, that's all for today, and thank you.